Hey everybody, talk a little bit today about radicals. Simplification of radicals comes up in our work, especially when we're dealing with things like the Pythagorean theorem. So let's just take something simple to begin with, like the square root of 60. Talk about the process by which we simplify a radical. Could also throw in some radical mathematics here at the end of this. So the way I think about this is, what square number divides 60? And so I'm thinking 4 times 15 is the same as 60. And so the square root of 4, the square root of 15, I can break those up. And now I have 2 square roots of 15. There's really nothing left to do because 15 is just 5 times 3. And so there's no perfect square there that's going to simplify this any further. And again, this can be used calculator to just check. I can take the square root of 60 and then look at 2 square roots of 15 and see that they're the same thing. Okay, if we have a bigger number, square root of, I don't know, 891, it's the same process. I got to look for numbers that divide it. A lot of this has to do with your strength and divisibility. For instance, I know the divide by 9 rule is that the digits add up to something that divides by 9. So 8, 9, and 1 adds up to 18. That divides by 9. So this is divisible by 9. I don't know what it is. 9 times my calculator. 891 divided by 9, 99. Already it's gotten a lot simpler. This is now 9 times 9 times 11. And so square root of 9, square root of 9, square root of 11. I guess actually that's a little silly because 9 times 9 is 81, which means 9 is going to come out of this. But anyways, the point is there's multiple ways to get there. 9 times the square root of 11. Now, before we move on, let's just talk briefly about the different operations. All right, square root of 6 plus the square root of 8. Square root of 7 times the square root of 2 plus the square root of 3. Even something crazy like the square root of 2 plus the square root of 3 times the square root of 6 minus the square root of 8. So in situations where you don't have a common radicand, there's nothing you can do because the square root of 2 and the square root of 3 are fundamentally different things, so they can't be added together. If I had the square root of 2 and 3 square roots of 2, then I could say, well, yes, I've got 4 square roots of 2, because basically this number, I like to think of it as kind of a variable, something that you don't really know. Not technically a variable because it's not varying, but it's like, what is the square root of 2? I don't know. So it's kind of the same problem as what's x plus 3x, which of course is 4x. Okay. In the case of the square root of 6 plus the square root of 8, I suspect the ending is going to be the same. Of course, the square root of 8 could be simplified. So I have the square root of 6 plus 2 square roots of 2. And, sometimes it may turn out that there's something hidden there that you can put things together, right? Like if I had given you the problem, the square root of 18 plus the square root of 8, those look like they can't be added together, but in fact, this is 3 square roots of 2, and this is 2 square roots of 2, and so in fact, this is 5 square roots of 2. All right, distribution, square root of 7 times the square root of 2 plus the square root of 7 times the square root of 3. So we're just looking at the square root of 14 plus the square root of 21. All right, last one, FOIL. Lots of stuff going on here. And I'll probably just do all the multiplication and then try to see what I can simplify. So I'm actually going to go ahead and erase a bunch of this stuff so I can kind of get back to the top. Again, being organized is a super critical part of success in mathematics. So I got the square root of 12, the square root of 18 minus the square root of 16 minus the square root of 24. Let's see what matches up, if anything. So 12. Well, pause the video and see what you come up with here. But 12 is 2 root 3. This is 3 root 2. This is just 4. Square root of 24. Oh, 2 root 6. Okay, so there's really nothing I can do at the end of this to simplify because square root of 3, square root of 2, no square root, and the square root of 6. There's no like terms really to bring together. Okay, so that's basic radical operations. The only one I haven't talked about is division, and division is similar to multiplication in that you can go in and out of multiple radicals. So for instance, if I got the square root of 18 divided by the square root of 2, that's just the square root of 18 divided by 2, which is the square root of 9, and the square root of 9 is just 3. Sometimes you'll see things like that, like 2 divided by the square root of 2. Well, that's the square root of 2 root 2 divided by the square root of 2. So this simplifies out to the square root of 2. 1 over root 2, rationalizing it, that's the square root of 2 over 2. What else? Yeah, I mean, I would just say the thing about the calculator is nice. It's in terms of like, did I do this correctly? I mean, sometimes just the presence of a square root will kind of freak people out, like square root of 5x minus 3. So if I have to solve this problem, the first thing I would say is, well, what if there were no square roots in the problem? What if it was just 3 plus 4x equals 5x minus 3? That's just to get your brain thinking about, what's my process? So I got to get my x's over here, my numbers over here. Okay, so that's not any different just because I have the square roots. Once I have that, of course, this turns out nice because this is just 1x, but I could just, once I get to a position where I have like 1x equals 6, I divide by the coefficient and then I'm finished. Now, it does look a little different. Shoot, I don't even remember what I wrote down. That's okay because I'm just making it up. So adding 1 to both sides, subtracting 2x from both sides, same idea, square root of 3 plus 1 equals the square root of 5x minus 2x. Now, sometimes here people get a little gun shy because they're like, well, what do I do with this? Well, there's nothing really to do because like we said in the previous problem, there's plenty of times with radicals where you cannot put the numbers together. So this is as good as it gets. Factor out the x, and you have yourself one step from the finish line. So you divide by the square root of 5 minus 2, divided by the square root of 5 minus 2. So x is the square root of 3 plus 1 over the square root of 5 minus 2. So this is as good as it gets. Now, if you want to rationalize it, you can, and we talked a little bit about that in a previous video. You have to multiply by the conjugate, square root of 5 plus 2 times the square root of 5 plus 2. And that would be a good exercise for you to check your binomial distribution, to check your simplification of radicals, and you can check some of that as an answer, right? A simplified answer, also a decimalized answer. Gotta get my Zoom stuff out of the way to see if it works, to see if the answer is approximately correct. Remember, when you use decimalized versions of things, it's only going to come out to be approximately correct. So you get prepared for that. All right, that's radical practice in a nutshell. See you.